My name is Andrei Pfeiffer. As I mentioned, I live in Timișoara, which is in the west part of Romania. You can find me on andreipfeiffer.dev. This is my blog that I'm currently running. I'm also very involved in the JavaScript community. I organize Team.js, which is the local JavaScript meetup here in Timișoara, and we also organize Revo.js, which is an annual JavaScript conference, not for profit, which hopefully we'll be able to organize next year again. And you can find me on Twitter, my handle being Pfeiffer_Andrei. Pfeiffer is spelled exactly like Michel Pfeiffer. So as I mentioned, today I would like to talk to you about a thorough analysis of CSS-in-JS that I have performed at the beginning of this year. What this analysis is basically more than a 2-month study of most CSS-in-JS libraries out there, which of course I cannot cover entirely in this 15-minute talk. So I will focus on only one small aspect of it. But you can check out the entire study at my GitHub page, github.com/andreipfeiffer/css-in-JS. The reason why I made this analysis, I wanted to explore a type safe to write CSS. As I mentioned, I used TypeScript in most of my application code, so to write the business logic and to write components. So I got all the benefits of type safety for the rest of the code, but the CSS part and the styling part are not natively type safe. So this is why I explored all these CSS-in-JS solutions to find a way to write type safe CSS. We were particularly looking for server-side rendering, libraries that support server-side rendering and being able to easily integrate with Next.js. And of course, we were looking for full TypeScript support. In this regard, we looked over most CSS-in-JS libraries out there. To be honest, there are more than 50 of them. We only looked over about 20, and we eliminated part of those because they didn't meet our criteria. So we only focused on about 11 libraries. Now, all of these libraries have so many things in common, which are documented on the GitHub page that I mentioned earlier. But today, as I said, I would like to focus on one particular aspect that also my Mark and Naman mentioned previously. I would like to focus on how these libraries output their styles to the browser. And I found that there are two different, let's say, mutually exclusive methods to make this possible. The first method is, I call it runtime style sheets, and the second one is static CSS extraction. And both StyleX and Vanilla Extract use this, the second method, static CSS extraction, or the zero-cost runtime, the so-called zero-cost runtime. So let's see how these two work from a very high-level point of view. So using runtime style sheets, it's important to mention that most CSS-in-JS libraries implement this method. And basically, when we define all the styles, they are within the JavaScript files, along with the components that we defined. So when we build our application using whatever bundler we have, we get a JavaScript bundle, a huge JavaScript bundle that contains the components, the application logic, but also the styles definitions as well. And of course, we need an additional code, let's call it the runtime or the library runtime, that has to be shipped to the browser, which basically knows how to read the styles and to inject them into the DOM so the browser can display the styles, because the DOM doesn't know how to read styles out of a JavaScript file. There are many different ways to perform this injection. I won't go into the details, but we can discuss this further during the Q&A. So let's move to the other method, the static CSS extraction. Well, As Mark and Naman mentioned, basically at build time, the library knows how to extract all those styles definitions from the JavaScript or TypeScript files and generate a static CSS file, an actual CSS file that you can include like any other style sheet into our document. And the JavaScript bundle will only contain the components and the application logic without any styles definition because they are already extracted as a separate file, which is pretty interesting. Now, there are two different things to talk about when we think about performance. The first one is the size, right? The size output. So let's look at a typical client-side rendering with runtime style sheets. So when we are doing client-side rendering, the HTML file that is shipped to the browser is usually pretty small. It's basically an empty container that will render everything on the client. We will get a huge JavaScript bundle, and part of this JavaScript bundle will be represented by the styles definitions, and as mentioned earlier. And of course, we need to ship that runtime to inject the styles into the DOM at runtime. When we are doing server-side rendering, there is something different happening. So the HTML file on one hand would be much larger because we are shipping all the rendered content that is already rendered on the server. And we also need to ship the so-called critical CSS, which is the CSS, the styles that are required to display the initial HTML page that is rendered on the server. All the JavaScript libraries that implement runtime style sheets will implement also support this critical CSS extraction and injection into the generated HTML file that is rendered on the server. So this is you get this out of the box. But it's important to notice that this critical CSS will be shipped twice to the browser. Once in the HTML file, and second in the styles definitions that is bundled with the JavaScript bundle. So it's a good thing to keep in mind this limitation. Now, when we are looking at static CSS extraction, the HTML file is the rendered HTML file. Let's say is pretty much the same. The CSS styles are a separate file, right? It's a CSS file that is pretty much the same size as the style definitions. There are slight variations, but let's consider for simplicity, let's consider that they are the same size. And the JavaScript bundle will be shipped as well. So we can clearly see that when referring to file size, static CSS extraction looks more appealing because we are shipping less bytes to the browser. And also keep in mind that CSS files and JavaScript files are very easy to cache by the browser, while HTML is not that trivial to cache. There are methods to do this, especially when we are talking about static CSS, static files, right? Static HTML. But when we are doing server-side rendering and dynamically rendering on the server or on the client, it's not trivial to cache. Now, as I said, from this point of view, like this static CSS extraction with zero runtime look really fantastic from this point of view. From the if we think about size alone, but let's look at another metric that we can think about. Let's look at time. So how long does it take to load these two different pages that use different libraries with different methods to output the styles? So this is an HTTP request, like a very basic representation of it, and it has two primary parts. The first one is the time to first byte, which is the time that it takes for the browser to make the request to the server to respond or to basically compute the response, and then for the browser to receive the first byte of information from the server. What influences time to first byte is latency, networking conditions, how the busy is the server, how long it takes to process the request, all that stuff. And the second part is the downloading part. the time it takes for the browser to basically download the entire file. Of course, smaller files will have a smaller download part, and larger files will have a bigger download segment. And also, it's very important to keep in mind that on a fast Wi-Fi connection, the download part is going to be very, very, very small compared to the time to first byte part. Right? You will see you would see this in Chrome DevTools or whatever the debugging console you are using. But on a slow mobile, for instance, the time to first byte will definitely be slightly longer, but the download part will be much, much longer in proportion with the time to first byte. So it's worth keeping these two scenarios in mind. And finally let's look at how a typical waterfall chart looks like when loading a page. So on top we have the runtime style sheets. On the bottom we have the static CSS extraction, and we are considering an empty cache. So nothing is cached at the moment, so everything needs to be downloaded. So we are downloading the HTML, which contains the critical CSS if we are performing server-side rendering. It takes some time to download that file, and after the file is parsed, considering that we are probably including the JavaScript files at the end of our document, those can begin to be downloaded and parsed as well. We can prefetch them, of course, and we can save some time, and we can optimize this process if we need to. But it's important to know that the first paint or the browser cannot start painting anything on the screen until it downloads the entire HTML file, and it parses and downloads all the resources that are specified in the head part of our document. If we don't specify anything in the head part, it can start painting right away, right? Now let's look at static CSS extraction. So with static CSS extraction, the HTML file is going to be a bit smaller, of course, but the time to first byte basically is pretty much the same if the server and the networking conditions are the same. And a static CSS file is usually included in the head part of the document. So, as I mentioned, the browser cannot start to paint anything unless before it downloads and parses all the resources that are included in the head. So, in this situation, the first paint will occur definitely later than in the case of runtime style sheets, because we need to make another request to the server to fetch the styles. Now, as Naman mentioned earlier, we can embed these CSS styles or all the CSS file into the HTML file. We'll download more content, but we can save this extra request and optimize this better. When you have a full cache, so on a second visit on or subsequent visits on our page, all the CSS files and JavaScript files will basically be cached by the browser, and the first paint will basically occur pretty much the same, but at the same time. But the first visit is definitely gonna differ a lot between these two different approaches. Now, it's worth mentioning that this is sample data. This is an oversimplified example. It might not apply to your use case. Of course, we need to include many other resources in the head or in the body of our document. So it depends on very many aspects to draw a definite conclusion which one is actually faster. Of course, this doesn't cover the time to interaction or other metrics that could be important for your use cases. But as a general conclusion, at least my own conclusion, looking at this mental model that I have created for these two methods, is that I look at runtime style sheets because I see them more suitable for client-side rendering and single-page applications when we are not required to ship that critical CSS along with the HTML file. And of course, we need fast paint, fast first paint metrics in this situation, because we need to paint as fast as possible something to the user, because we need to fetch additional resources while yes, after the initial HTML file gets to the browser. With static CSS extraction, on the other hand, you get less bytes transferred, and we also get better caching. So from my point of view, it looks more suitable for server-side rendering or static pages. So there are, I think, I look at them as two different methods that better suit different situations or different use cases. Of course, in the case where we have let's say a hybrid solution, that we have also highly dynamic pages, but also static pages or server-side rendered pages. That's where it gets more complicated and tricky. So as we can see from this graph, most of the libraries like Style.jsx, Style Components, Emotion, Type, Style, Fella, Stitches, Goober, and Compiled support the runtime style sheets. Static CSS extraction is not that popular. Vanilla Extract, Linaria, and AstroTurf, as far as I know, implement, and Stylex, of course, implement this method. Also Compiled, which is a library from Atlassian, added experimental support, but is not released yet. So yeah, I can see that more and more libraries start to also to tackle this method as well. So you can check out the full analysis at my GitHub page. It covers a lot more information and a lot more topics and features that all these libraries have to offer. So with this, I thank you all, and if I'm open to discussions, if you have any different opinions about the way these things work and the way I presented them, I'll be happy to discuss them. Thank you.
Thank you so much, Andrei. That was a wonderful insight on all CSS-in-JS libraries.
Thank you. Thank you.
No, okay. Okay, there's one from Naman. Did you come across a library that statically extracts CSS but also implements critical CSS?
I don't think so. I mean, as far as I understand, I don't think that's extracting the critical CSS is part of the CSS-in-JS library. I think it has to do something. I think it should be something done at the framework level or at the application level. And I know for a fact that Next.js, I don't know if they shipped this support, but they will be shipping this feature soon. So when performing server-side rendering, to ship the critical CSS as well. So no, to answer your question, no, I don't think so. I don't think so.
I do just want to. Oh, sorry, you go.
Yeah. No, I was
just going to say a couple of things. So Vanilla Extract, on this topic, Vanilla Extract, we don't talk about it much, but it actually does have a fallback runtime version. It's more there for like testing. So if you run your code in Jest, for example, like the actual like CSS code will execute. But importantly on this question around critical CSS, we don't officially support it yet, but Matt Jones, who's like written the most lines of code in Vanilla Extract, he's actually literally just in the last week or so got like a prototype of this working with Vanilla Extract. And this is basically by like, because of the TypeScript code that you write in your style sheets, you effectively just like execute the code in the server rendering environment, and then we have a method of keeping track of which classes actually got referenced in the HTML. You have to analyze the HTML file to see which classes got used, but then we can pull those styles into a style tag at the top of the page. So it's not something we officially support at the moment, but there may be something soon.
But I mean, I have a follow-up question here. Like, how does Vanilla.js or the CSS-in-JS library know what is a page in your application?
Yeah, so the trick is you have to feed it a string of HTML. That's the way it works basically, because it keeps it generates all the styles and keeps them in memory, and it says, okay, well, I know all of the CSS that could possibly be referenced, and then you say, well, here's a string of HTML. Give me what I actually used. That's basically the trick.
Okay, got it.
The thing that I prototyped for StyleX is pretty much the same. It's a big map of all the class names, and then you just pick out the ones that you actually used on first render.
Cool.
And also, I would like to make one regarding critical CSS. One thing that for me was really confusing when I first encountered this term critical CSS when talking about CSS-in-JS is that it doesn't refer to above the fold critical CSS. Like if you search on your favorite search engine critical CSS, you will not get any of the CSS-in-JS critical CSS. You will get a lot of articles about the above the fold critical CSS, which means the CSS required only for the first part, the top part of the document. And these CSS-in-JS libraries do not extract that above the fold critical CSS. That's something that is not trivial to perform, and it's very difficult. So just to keep that in mind, I think it's very important to understand the differences between these terms.
I'm actually unsure how to even do that manually, because how do you decide where the fold begins?
I've never been a believer in that approach personally. Like I've always felt it, the thought of like, what if your connection's a bit slow and you scroll down? What are you even looking at? Is the bottom half of the page broken? It doesn't sound right to me.
Yeah, it's very complex to do that. There are some libraries that use different techniques to extract this, but I don't think it's very, very safe. And it can guarantee that all the styles required for that above the fold part will actually be extracted properly.
Andrei, I have a quick question. Of all the CSS and JS insights that you showed, what's your favorite one and why? Like what you have been using the most?
Again, I try to be unbiased towards these libraries. As mentioned, I use the treat and will migrate to vanilla extract, but only because we had to perform server-side rendering. So this is, and we wanted to have a good caching of the resources. We had, the solutions basically are not highly dynamic. It's pretty much, our use case was pretty much the same use case as Mark's solution that they are working on. So it resembles pretty much the same needs. That's why I choose that particular library. But if I was to work on a single-page application, highly dynamic application, that's difficult. I don't know exactly how to answer that question. So it's when you get to specific, it's easier to talk about specific applications, specific use cases than to talk about generic ones. So I cannot say that I have a preference for one or the other.